Hi guys, so today we will start our DP section of CSES problem set. So this is the first problem of this DP section, that is dice combination. So I will read out the problem statement. It's pretty much straightforward. Your task is to count the number of ways to construct some n by throwing a dice one or more times. Each throw produce an outcome between 1 to 6. So we have given example here. So that is, let's say if I want to make the sum 3, so there are basically 4 possible ways to reach to the sum 3. Let's say if you just roll the dice and you get 3, then you can just count it as a way you can get to the 3 in a single go. And let's say if you roll the dice and you got 2 and then you got 1, so this is one other way. And let's say if you roll you get 1 and then 2, so this is another way. And let's say if you get 1 3 times in a row, so that can also make up 3, right? So these are the number of ways, and our task is to output how many ways are possible for a given n, and the range of n is from 1 to 10 raised to the power 6, and the number of ways can be too many and it cannot be fit in int or long, so that's why we have to answer the number of ways by module of 10 raised to the power 9 plus 7. So I will also tell when to module, right? Yeah, so this is pretty much the problem statement. Now we will encounter this. Now we will go one by one, like how we have to build our DP, right? And also I wanted to tell you, in this section I will try to solve the DP problem with iteration method, not the recursive one, because even like if you do by iterative method, this will help you build the understanding of your code, right? And this will improve your implementation, right? Even I can do by recursive as well, but I guess this iterative method is more more good, the actual way of doing the DP problem, right? So yeah, I have written some notes for you. So whenever you are solving a DP problem, you should keep 3 things in mind. First thing is, what will be your DP state? Now what do I mean by state? Basically I'll write for you. Let's say if I want to discuss point 1, what will be your DP state? DP state. You like if you guys have studied about functions, then this is pretty much same. Let's say if you have any variable x, and what does the f of x represent? That's the function of x, right? Similarly, this is called the DP. It's just a fancy word. So let's say if I want to find the number of ways to make some, let's say I want to find the number of ways to make some I. So in this case, my state can be represented by dp of I. Now what does the dp of I represent? I want dp of I to be my final answer. So that's why this dp of I represent the number of ways to make some I. Number of ways to make some I. And what does this I represent? I represent the sum which we are reaching. So I will make this small I. Yeah. So this I represent the final sum we are reaching, right? So in this case only, if you consider the example of I equals to 3, which we have seen in this particular example only. So in this case, your I equals to 3 and your dp of I will be the number of ways to reaching 3. So dp of 3 basically is 4. So this is what the state of dp. And state basically means how many parameter you want here, so that your dp can be a unique function. So when I talk about function, let's say if you are you might have seen some function which are in terms of x and y. Let's say if you and there can be multiple variable as well. Let's say if you have seen some function which is in term of x, y, z, and like so many. So these x, y, z are basically basically independent variables, right? Independent variables. And this f is your dependent function. So basically it's a dependent function, right? So in this case, in this similar case which we are talking here, your f is basically this the function, and the x, y, z, these are the states. So how many states you need to make your dp, and we have to minimize the number of independent variable we need here to make it a unique number, right? So this was just a pretty much this was the explanation. So I think now you have understood what is the state of the dp, right? And now I will talk about the other thing. So what will be your base condition? Base condition basically means from where you will start your dp. So in this case, I'm making my sum. Let's say in this case, if I am making my sum from starting to end, then just consider my I is equals to 0 in starting, and I wanna reach I equals to n. Do you know the answer for I equals to 0? Can you tell me that? So basically this represents the number of ways to make sum 0. So if you want to make the sum 0, then you just won't roll the dice. You won't roll the dice, otherwise it will make up some sum, right? So there is only one way to get the answer 0. So this is your base condition, right? Base condition. Yeah. So the third thing we have here, what will be the transition of your dp, right? So for the transition of your dp, what does this mean? Basically is that, is there any function, let's say, is there any state which you have already calculated, and this can make up to get your answer for a higher state? So let's say if I want to find the answer for dpi, so is it possible to get it from previously calculated dps, right? So basically lower I. So in this case, yeah, it is possible. So let me tell you an example. Let's say if you wanna find the answer for dp of x, if you wanna find the answer for this, and let's just assume that you have already calculated the answer for every number that is smaller than x, right? So is it possible to reach dp of x from that any smaller answer? So let's say if I have dp of 3, so dp of 3 can be reached by dp of 0. How is this possible? By rolling dice and get 3. Rolling dice and get 3, right? Yeah, so dp of 3 can be reached by dp of 0 by rolling the dice and get 3. And similarly, let me just write these all things in new line. Can be reached by this, and it can be reached by dp of 1 also, and by rolling dice and get 2, because if you have already found the answer of number of ways to get to the 1, then you can just use these ways and just roll one more time, and you can get 2 and you can reach to 3. Similarly, it is also possible to reach from 2 by getting 1 by rolling dice and get 1. So every time now you can make up the pattern. Every time when you have to calculate the answer for dp of x, you can simply get it by dp of x minus 1 plus dp of x minus 2 plus dp of x minus 3 plus, and so on to dp of x minus 6. Now this is because every time when I roll the dice, I have possibility to get the answer from 1 to 6. So let's say you can just pick any state. Let's say if I am picking this one, I can simply I simply know the answer for this thing, and you know that I can just roll the dice, and if I get the 3 from this state, I can move to my dpx. So simply dp, the number of ways to get to the dpx will be x minus 1 to x minus 6, right? And also you have to make sure that this x minus 6 is not getting negative. This every time this index is not getting negative, because let's say in this case for dp equals to 3, we have only gone to the 0, 1, 2. We have not used some lower indices, because negative is not possible here, right? So this is called your transition. Transition basically means that is it possible to get to a current answer from previously calculated answer. So basically I will just write here, I will write this line here. Transition basically means I was talking about this one, right? So your dp transition means that is it possible to get to the current answer from previously calculated answers, right? So this is what your transition means. So in this case we have seen the transition is this one, right? So now I can write my code. So it's pretty much simple now. You know your base condition is this thing, your dp 0 equals to 1, right? Now I want to calculate everything, let's say from int I to, let's say, n, or whatever the maximum number you want, right? I just want to calculate every dp, right? And you can calculate it by dp I and apply transitions, right? Apply transition, because in this case you have calculated the answer for the lower i's, right? So this is pretty much straightforward. Now I will show you the code. Yeah, so here as you have seen in the problem statement, the maximum value of n can be 10 raised to the power 6. So I have made the dp of 10 raised to the power 6 plus 1, and I have initialized everything by 0, but by default vector will initialize that for you by 0 only, right? Now this is my base condition. My base condition is that I am initializing the number of ways by the number of ways to get to the 0 by 1. Yeah, now I want to calculate the answer for every I that goes up to 10 raised to the power 6, because my maximum value of n can be 10 raised to the power 6, right? Now for a current value of I, I'm keeping a variable that is result. Now I will go through the last six states, right? And in any case, if my state is getting negative, I don't want the answer for that. I don't want my index to be negative, right? So at that point I will just break my loop here, and this will just go previously to the 6 states, and it will just add up the answer for the states to my result variable. And you know, as we are just adding this answer and result variable, we want to make sure that it won't overflow. So every time when I add something to the result, I want to make sure that it won't exceed my mod. So that's why I'm taking the mod with my this mod value. So this is the variable I have initialized it by 10 raised to the power 9 plus 7. So it's a global variable in my boilerplate. And also there is a couple of things in my boilerplate. I will be providing the link to the same in the description and also in the end of the video, right? So I have applied my transition, and now I have calculated my current answer, and I have just put this in my dp. And similarly, this loop will go on. It will calculate the answer from starting I to the end of the i's, right? And finally, now you have answer for every n. You can just take the input and you can just give the answer back. So that was pretty much a straightforward problem, but my goal was to explain you a generic thing generic things that will help you to solve every DP problem. So thank you.